In the first few problems, we're asked first to determine what the domain and range are for each relation, and then to determine whether each relation is a function. So we're going to use set notation to describe the domain and the range. Set notation starts with a capital D, is followed by an equal sign to say this is going to be my definition. The curly bracket represents a set of numbers, so it does actually have to be a curly bracket. Parentheses or square brackets are not an acceptable substitute. And we always state what the variable is going to be, so we've got x and then a colon. When we have a list of numbers like this, we want to list the numbers in order from least to greatest. So as I'm looking at those x values, I see -5, 1, and 3. Notice, although there are 2 3s on the points, once I've stated that 3 is an element of the domain, I don't need to say it again. I already put it in the domain, so I wouldn't list 3 twice. The range has capital R as its abbreviation, and since the range talks about the y values, there's a y in there before the colon. And again, we list the numbers in order from least to greatest. This time, each of the numbers gets listed because they're all unique. Remember, the definition of whether a relation is a function is that each x has exactly one y. So I need to look through and see if that's true. I immediately notice these 3's. First 3 is paired with 4, then 3 is paired with 7. So this is not a function because the value of 3 has more than one output value paired with it. So we would state that this is not a function because the input of 3 has more than one output, both 4 and 7. In example B, there conveniently are not that many numbers to deal with. It's a very short set, only 2 points. So the domain is all the x's, 8 and 9, while the range is all the y's. Oh, that's a terrible curly bracket. Just 7, because the 7 is repeated. We want to remember that we determine whether something is a function by looking at whether the x values are paired up with more than one y. 8 is only paired with 7, and 9 is only paired with 7. So each x has only one y. It doesn't matter that it happens to be the same y. So we would say that this is a function because each x has exactly one y. All right, let's take a look at the next example. In part C, instead of being given our points as a list, a set of points, we're given a mapping diagram. Mapping diagrams make it really easy to write out domains and ranges because your domain is already gathered up in the first bubble and typically listed in order from least to greatest. And your range is all gathered up in the second bubble, again, already ordered from least to greatest. Again, it's very easy for functions. I can look very quickly and see that there are 2 arrows coming off of 4. That makes it blatantly obvious that 4 is paired up with more than one output value. So this is not a function since 4 has 2 output values, both -2 and +6. In the next couple of problems, we're not asked to take the time to list the domains and ranges, just to explain whether or not these things are functions. So this time I'm giving my values represented in a table. I have 3 points represented in a table. Now I don't want to get distracted by the fact that some of the y values repeat. Each of those x's is unique. There's a 6, a 1, and a 3. Each of those x values has just one y value paired with it. So this is a function because each x has only one y. Taking a look at the next problem, it's pretty simple as well. There are only 3 points, just like the table had only 3 points. And again, we're asked, is this relation a function, and to explain why or why not. So as I look, I see 0, 3, and -1. That's 3 unique x values. With 3 unique x values, it's just like the previous problem. This is a function because each x has only one y. Okay, now we're asked to look at evaluating a function. When we evaluate a function, we're being asked to substitute a value for x. So if they say evaluate f of x equals 2x minus 6 for x equals -2, they're saying what is the value of f of -2? In other words, take out x and in its place write a -2. Now we have a numerical expression that we can simplify according to the order of operations. First, we have to multiply. 2 times negative 2 is negative 4. Then we can do the subtraction. And so we can see that the value of f of negative 2 is negative 10. Notice that's not f times negative 2. It's f of negative 2. So the f and the negative 2 are not multiplying. In the next problem, we have if f of a is equal to negative 3a plus 5, find the range of the function for the domain negative 3, 1, and 4. So remember, domain is the input values. We are being asked to plug each of those in and find out what the output values are. So I'm going to set up my notation. The range is going to be the following y values. Well, f of negative 3 says take out a and put in negative 3. So following the order of operations, I have 9 plus 5, or 14. F of 1 says take out a and put in 1. So negative 3 plus 5 is 2. And f of 4 says take out a and put in 4. So negative 3 times 4 is negative 12, and negative 12 plus 5 is negative 7. I do want to list my numbers in order from least to greatest, which is why I didn't start putting them in the set until after I knew what they all were. So I can see that I want negative 7 to 14. And that answers the question. That's my range. We're given another function, g of x. So g of x is x squared minus 5. We're asked to evaluate and find out what is the value of g of 3 and what is the value of g of negative 2. So g of 3 asks us to put 3 in place of x in the problem, and then follow the order of operations. 3 squared is 9, and 9 minus 5 is 4. Then to find out g of negative 2, so that asks us to put negative 2 in place of x and follow the order of operations. Negative 2 times negative 2 is a positive 4. Positive 4 minus 5 is a negative 1. So the two responses are 4 and negative 1. Finally, we have a little word problem to take a look at. It says Lauren has 4 rolls of ribbon to make party favors. We're told that each roll can be used to make 30 favors. So there are 30 favors in each roll. The function f of r equals 30r represents the number of favors, f of r, that can be made with r rolls. What are a reasonable domain and range for the function? And then make a graph. So we're not just talking about some random math here. We're talking about a tangible situation. If r represents the number of rolls, well, I only have 4 rolls. So that's all that we can work with in this problem. I can use any amount of those 4 rolls I want, but I can't use a negative number of rolls because that's not really a thing. So I would probably say that the domain, notice I've got r in there instead of x because we don't have an x in our problem. The domain for r would be 0 is less than or equal to r, which is less than or equal to 4. There's one of our compound inequalities from Unit 3. I'm saying r is any number between 0 and 4. We could use all of the ribbon, which is why it could be equal to 4, or we could choose not to make anything at all and use none of the ribbon, which is why we also have the or equal to with the 0. Now, f of r represents the number of favors. Well, thinking about the practicality of this, the range, capital R, of f of r, our y value, is going to be 0 is less than or equal to f of r, but it's got to be less than or equal to something, and at the moment we don't know what that something is. So we need to think the problem through just a little bit more. We said the most we could possibly use is all 4 rolls. So if I used all 4 rolls, that would be f of 4, which is 30 times 4, or 120. So if the greatest number of rolls I can make is 120, then that's the maximum in my range. Now we're asked to graph the function. Well, we know if we don't use anything, we won't make anything. So the point 0, 0 is our first point. We know that our highest point is 120 favors for 4 rolls. So it seems like a scale of 1 to 1 on the x-axis will be perfectly fine for number of rolls. But a scale of 1 to 1 is really not going to work out on our f of r axis. So this is our r axis and our f of r axis. So if I were to count, for example, by 20s, 1, 2, 3, 4, 5 would put me at 100. And then two more, or actually just one more up would get me to 120. So that seems like a scale that would work out pretty well. At 4 rolls, I'm at 120 favors. Since this goes up by 30 every time, I'd be here, and then here, and then here, and then on our final point. Now, the question becomes, do we kind of connect the dots? Do I draw the line segment that goes in between those 2 points? Well, this is a little bit tricky. I probably wouldn't make like a part of a favor. I would either make the favor or not make the favor. But I can use any portion of the roll I want to. So there's actually a thing called a step function that we're not really going to learn about in Algebra 1 that would be the most appropriate representation here. But a line is actually a pretty good representation because I don't have to use the entire roll if I don't want to. And by connecting those dots, showing that that's a continuous function, I'm showing I can make just like 23 favors, or I could make 13 favors. I could use just a portion of the roll.